Newton's second law. We learn from the first law that the body will stay at the same speed as long as the net force affecting on it is zero. The second law detects what happens when a force acts on an object. In this case it no longer has a constant speed. It will accelerate. Newton's second law states that the acceleration of an object is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. So, as long as the net force is zero, we will go back to Newton's first law, where the velocities stay constant with no changes versus time. But if some force suddenly pushed the body, its velocity will start changing, and it will keep increasing or decreasing until the force stops affecting on this body. You must have noticed that when you push the accelerator in your car, the speed will increase because the engine is using the gasoline energy to push the car toward. But after some time, the speed will stay in constant amount even though you still pushing the accelerator. Why the force is not affecting on the speed anymore? Why it act like Newton's first law? It is because of the air resistance. The faster we go, the stronger air force will be. And it will keep increasing until it become equivalent to the engine force. In this case the net force will be zero, which keeps the speed in constant amount as the first law predicts. But if there is no air or friction, any object pulled by a force will keep increasing its speed forever. The bigger the force, the faster will go. The only resistance will be in this case is the mass of the object, as the second Newton's law predicts. Suppose we have different objects with different masses, and they are all pulled by the same amount of forces. It is very important to keep the force constant and similar for all of them to make sure that we are playing only between the acceleration and the mass. As we can see, the smaller the mass, the higher acceleration they are moving. In another word, the bigger the object, the lazier it would be. Now, let's play between the force and the acceleration. Let's have different object with the same mass, but they are pulled by different amount of forces. In this case, the bigger the force, the higher the acceleration. In another word, the stronger the faster. As you see, there are three variables in this law: the force, the mass, and the acceleration. And we know the relation between the force and the acceleration. We also know the relation between the mass and the acceleration. But is there relation between the force and the mass? The answer is no. The variation of mass has nothing to do with the force. And pushing any object will not change its mass. But these two variable effects on the acceleration, their ratio is equal to its amount. Very simple.